Okay guys, today I'm going to do a quick tutorial on hotspot volcanoes. This is an animation that was created to kind of explain how hotspot volcanoes work, how a chain of volcanoes occur. So it's based on understanding that this is the asthenosphere down here, which is able to flow in a convection current. And up here is the lithosphere, which is what is divided into plates. And the lithosphere is in this case, the oceanic crust right here, which is made out of basalt, plus the upper part of the mantle. All together, that makes the lithosphere. All right. So one of the things we need to make sure you understand is that the hotspot itself and the hotspot volcanic island chain does not typically occur along a plate boundary. So this is happening within a plate, which is what makes them unusual and makes scientists unsure originally of how they were formed. All right, so I'm going to play the animation here, and you're going to see what happens. All right, so this animation is showing how this chain of volcanoes was formed. And you can see there's the hot spot, and it's kind of a weakness in the asthenosphere that comes up through the crust. And that weakness, that heat, is really generated from deep down in the mantle. The lithosphere, it begins to erupt and forms a volcanic island once it gets high enough. And in this case, it's all basaltic because it's formed from the ocean floor. So it's forming as the plate motion is moving from left to right. Keep in mind, the hot spot does not move. Continues and the plate moves off that hot spot, that volcano becomes inactive. It becomes extinct, so it won't erupt again. But meanwhile, new seafloor is over the hot spot, and that is beginning to form a new volcano. Enough that it becomes an island, but the plate continues to move, and as it moves off of that particular volcanic island and forms a new one, and so on. Each time that the old volcano becomes extinct and the new one is formed. Okay? So over a long period of time, the plate movement over the hot spot generates a whole chain of volcanic islands. Right? Two key bits of evidence that support that idea is that when we look at the age of the rocks on the islands, the lava rocks, the igneous rocks on the furthest island are the oldest, and then they get younger and younger, with the youngest rocks being found on the currently active volcanic island. In this case, it's the Big Island of Hawaii. The second thing that supports this idea is that there's only ever one volcano that's active, or one island that's currently active. So these guys have been extinct and they've never erupted again. This is the only active one. All right. And actually right now, the Big Island of Hawaii is moving off of the hot spot, and a new island is forming. It's not an island yet, it's below the sea level. All right. So this is how a chain of volcanic islands form from a hot spot.